The question of whether there is life beyond Earth has fascinated humanity for centuries, and one of the most tantalizing prospects in this search lies on Europa, one of Jupiter's moons. With its vast subsurface ocean, Europa holds more water than all of Earth's oceans combined, twice as much, in fact. This revelation alone has scientists buzzing with excitement, because where there is water, especially in the form of an ocean, the possibility of life becomes a compelling possibility. Today, we have not one but two significant discoveries about Europa that have provided new insights into this question. A recent study, utilizing a magnetometer aboard a spacecraft, found a magnetic signature while flying close to Europa. This signature is familiar to scientists and suggests the presence of an electric current flowing beneath the moon's icy shell, potentially indicating an ocean beneath the surface. Europa, one of Jupiter's four largest moons, is about the same size as Earth's moon but looks strikingly different. Its surface is smooth and bright white, covered in ice, with dark lines and reddish patches scattered across its expanse. What makes Europa stand out is the theory that beneath this icy shell, it harbors a global ocean, a vast body of liquid water that could provide the right conditions for life. In fact, scientists believe Europa's ocean contains twice as much water as Earth's oceans combined, a discovery that has raised the possibility of extraterrestrial life to an exciting new level. The ingredients for life that we find on Earth, water, energy, and organic compounds, seem to be present on Europa. And yet, while these factors suggest life could exist there, significant challenges remain. The surface of Europa is incredibly harsh, with temperatures plummeting to about -160 degrees Celsius. Such extreme cold would freeze most life forms found on Earth, making it difficult to imagine how any form of life could survive there. The lack of an atmosphere also means Europa has no protection from the intense radiation emitted by Jupiter's magnetosphere. This radiation is far stronger than anything we experience on Earth and would pose a deadly threat to any organisms trying to survive on the surface. However, beneath the thick ice shell, things might be very different. Europa's subsurface ocean, shielded from the brutal conditions of space by the thick ice, could provide a stable environment where life might thrive. The ice acts as a protective barrier, preventing harmful radiation from reaching the ocean below. But even here, there are challenges. The ice is up to 30 kilometers thick, making it difficult to access or even study the ocean beneath. Scientists are still unsure how the ocean interacts with the icy surface, and whether it has the right conditions to support life. Despite these hurdles, there is hope. The warmth from the ocean, the possibility of chemical nutrients, and the protection from radiation make the idea of life on Europa an exciting possibility. There's still much to learn, and researchers are working tirelessly to uncover whether life could indeed survive in this frozen, isolated world. How scientists study Europa. Studying Europa is no easy feat. Its extreme distance from Earth, combined with its harsh surface conditions, presents significant challenges for space exploration. Nevertheless, space agencies such as NASA, the European Space Agency, ESA, and others have been developing missions aimed at unraveling the mysteries of this intriguing moon. The Galileo spacecraft, which orbited Jupiter from 1995 to 2003, was one of the first to provide critical data on Europa's surface and atmosphere. However, it could only conduct brief flybys, limiting its ability to delve into Europa's deeper mysteries. More recently, NASA's Hubble Space Telescope detected plumes of water vapor erupting from the surface of Europa, suggesting that its subsurface ocean could be venting into space. This exciting discovery has the potential to offer scientists direct access to Europa's ocean without having to drill through the thick ice, a breakthrough that could accelerate our understanding of the moon's potential for life. One of the most anticipated missions to study Europa in greater detail is the Europa Clipper mission, set to launch in the 2020s. This spacecraft will make detailed flybys of Europa, using a sophisticated array of instruments to study its surface, ice shell, and subsurface ocean. The Europa Clipper will be on a mission to determine whether the conditions for life, especially microbial life, exist on Europa. By analyzing the plumes more closely, the spacecraft will attempt to detect signs of organic molecules or other indicators of biological activity. In the future, researchers hope to send landers or even drilling probes to Europa's surface to collect more precise samples and probe the depths of its subsurface ocean. Such missions could provide a treasure trove of information, revealing whether the Moon harbors life, and offering profound insights into the possibilities for life elsewhere in the cosmos. What kind of life could exist on Europa? Given the harsh conditions on Europa, scientists are focusing on the possibility that if life exists there, it would most likely be microbial. Earth offers numerous examples of extremophiles, organisms that have adapted to survive in extreme environments, like deep-sea hydrothermal vents, acidic hot springs, and frozen tundras. These life forms thrive without sunlight, relying instead on chemical energy sourced from the Earth's crust or chemicals dissolved in water. Europa could be home to similar extremophiles. If microbial life exists, it might draw energy from hydrothermal vents in the subsurface ocean or other chemical processes occurring beneath the icy shell. Some researchers believe that the ocean could contain organic compounds, essential building blocks for life, that form through chemical reactions between water, minerals, and the energy from Europa's rocky core. One of the most intriguing possibilities lies in areas where the subsurface ocean meets Europa's rocky core. In these regions, hydrothermal vents could provide both heat and nutrients, creating a habitable zone in an otherwise frozen environment. Additionally, changes in the thickness of the ice shell could create temporary habitable zones that might allow life to persist under specific conditions. The role of hydrothermal vents in life on Europa. Life on Earth flourishes around hydrothermal vents on the ocean floor, where superheated, mineral-rich water is released into the surrounding cold ocean depths. This creates a thriving ecosystem that survives despite the lack of sunlight. Europa's ocean, though much colder than Earth's, could share similar characteristics. Tidal heating, caused by the gravitational interactions between Europa and Jupiter, might provide enough heat to power hydrothermal vents on the ocean floor. These vents could provide the energy and chemicals necessary to support microbial life, much like Earth's vents sustain deep-sea ecosystems. If such vents exist on Europa, they could serve as the basis for a microbial ecosystem, where simple organisms might thrive in the dark depths of the ocean. The discovery of hydrothermal vents on Europa would be a groundbreaking finding, supporting the possibility that life could exist there and offering a deeper understanding of the conditions under which life can survive in the most extreme environments. These vents could also release organic compounds into the water, providing a potential source of nutrition for any life forms that might inhabit Europa. The future of Europa exploration. As we move forward with the exploration of Europa, it's clear that the coming decades will bring thrilling new discoveries. The Europa Clipper mission, set to launch in the 2020s, will be the first in-depth study of Europa's surface and subsurface features. Using advanced scientific instruments, the spacecraft will fly over Europa, take detailed measurements of its icy surface, studying the plumes, magnetic fields, and other critical data that could offer clues about the Moon's habitability. Further exploration might involve landers or even drilling missions designed to access Europa's subsurface ocean directly. These missions would give scientists the tools they need to make a definitive determination about Europa's potential to harbor life. Conclusion: Europa's place in the search for life beyond Earth. Europa is one of the most compelling places in our solar system to search for signs of life beyond Earth. Its subsurface ocean, icy crust, and potential energy sources create an environment that could support life, despite the extreme challenges posed by its surface conditions. Whether microbial life or something more complex, Europa presents an exciting opportunity to study life in a vastly different environment than what we know on Earth. Exploring Europa is not just about answering the question of whether life exists there, it's about understanding the broader conditions that make life possible elsewhere in the universe. The discoveries made on Europa will deepen our understanding of biology, chemistry, and the potential for life beyond our planet. As we continue to study Europa, we move closer to answering one of humanity's